All right, so this is the hexa mesh which I made in the ICM CFD. Okay, and this mesh has around. So let me check. First, we have to convert to unstructured mesh. So in this mesh, the number of cells are around 6.65 million. So it's a little bit less than the 0.8, but number of nodes are higher. The number of nodes in the tetra meshing were around 3 lakhs. Here is 6,45,000. So it's almost double the number of nodes than the tetra meshing. So this will affect the solution very much. Okay. So now we have to output the mesh. I will choose the simple things here. We have the band that is going to be the wall. Okay, and wall 1, wall 2 will also be wall. So I will simply copy this boundary condition from band and paste over here. Okay, inlet is a velocity inlet. And outlet is the pressure outlet. Okay, now accept, again save, and now you have to export the mesh file. So this is in the fluent format, so the file format would be the MSH, and this is the band 90 degrees. Okay. Okay, now we have to duplicate this system once again. So I will only change the mesh in this setup, but I will not change anything at all. So this RKE will be RKE, everything else will be same. Okay, so mesh has no issues, and I can close the mesh file, ICM CFD file from here. Okay, so this is the RKE and the hexa meshing. So what I'm going to do is that I can basically I can open setup, and so open setup. I think we can get that option here, or maybe not. So let me check, or maybe we have to create the fluent part separately, and we have to set everything again from scratch. So if I can replace a mesh file, then that would be a good thing. If this is a gray color, then I cannot replace mesh file. So just wait for this thing. Okay, so we can replace the mesh file. So I will replace the mesh file. Okay, so this mesh file is over here. So this mesh file. So basically we are replacing only mesh file, and we are keeping everything else intact. So everything else is same, exactly same. And boundary conditions, troubles model, everything is same, but I will check it once again. So to just confirm the things. Okay, I will also click on the report quality. So report quality says that we have the quality of 0.6. It's very nice. And if we display mesh and make it different colors, this will look like this. Okay, then I want to just confirm that the material properties are exactly same, 1000 and 0.001. Yes, exactly same. And in the boundary condition, the inlet boundary condition is 6 meters per second. Everything is same. So in the methods, okay, so now we will run the calculation again. So we didn't initialize solution by ourselves. That's why the Fluent is initializing solution automatically by using the hybrid initialization method. So just let it do. Okay, I want to use these settings for current calculation only. Okay. And I hope that with the hexa meshing, the solution convergence will be faster. And second thing which I'm expecting very positively is that the results will be better than the tetra meshing. And also I have set up the velocity monitor. So now let's wait for the solution to converge. Okay, so now you can see the solution is almost converged. Okay, so I will stop solution here. And the next thing is that I want to see that we have the line. No, we don't have the line here. So I need to create line again. So line. And the points are 0.015 and 0.025. Okay, this line is over here. Okay, so the next thing is that we have to plot xy plot, and it will be along y-axis, and it's a velocity, it's the x velocity, and on the line number 11. Okay, so now we have to write this file, and this is the velocity profile and RKE, but this is with hexa meshing. Okay, again the same procedure. So this time I will be moving this graph over here and copy this whole thing from here. Okay, I think we should make the colors up to here. Okay, so this is like borders all to up to everything, and color is like this, and copy and paste. Okay, so this is going to be the for hexa meshing, and delete everything from here. Okay, so first now we have to import data. So for that, make a new sheet. So from the text, and this is going to be inside the Fluent DP0, Fluent FF2 and Fluent, and all files. This is the velocity profile RKE hexa meshing. Okay, so we have to process data, as you know already. So we have to divide by 0.01. This is the diameter of pipe. And we have to subtract 2 from every data point to make it from plus 0.5 to minus 0.5. Okay, then we have to normalize the velocity by dividing 6, which is the inlet velocity, and drag it for all the values. Okay, now copy this these two columns, and we'll paste into our main sheet, which is over here. Okay, so data points are a little bit lower. Okay, so I will delete these columns. These are extra columns. Okay, so now as far as the graph is concerned, so graph is over here. Okay, right click here and add the data. So this is the RKE, CFD RKE, but it's a hexa meshing. and the data points are these ones. Okay, so we have the CFD RKE hexa. This is CFD RKE. So you can see that data here is slightly better, but here is the offset. So now we cannot say anything. It's almost mixed thing we are seeing here. But the only thing which I can observe very easily is that data is very smooth. There's no wiggles in the data and it is going very smoothly. But the changes are almost same. So now I will conclude this project, this workshop here. So I'm going to provide you these three files which I've shown you in the videos. So one is with the 0.8 million mesh size with the geometry I drawn in the space claim, and I use the SST model, RK model, and then the RK model with the hexa meshing which I created in the ICM CFD. And the second file which I'm going to provide you is the files which I started with this whole exercise. This is these are the over here. So you will also get this file. Okay, so band 90s and 90 degrees band curvature ratio 2, and this contains the 4 mesh files. And so I can give you briefly these things. So these are 3 meshes, and then I made the fine mesh. I refined the mesh, medium mesh, and I made the 2 spheres like this. So the mesh becomes the 1.05 million. So this is the refined mesh from the medium mesh. So this is the medium refined mesh. So again, results are almost similar. Okay. So you will get these files also. So now you must know that the difference between this workbench file is that this is the things I have shown you in the slides. This is exactly the same method. But then I have to demonstrate the whole procedure in the video. So I made the new files. And the new files are the SST, RKE, and RKE hexa. And definitely the mesh size is slightly different. It's around 0.8 million cells. So, but the important point is that you have learned that how to get the data from the paper, and then how to translate that data into geometry, meshing, and the problem setup in the Fluent, like boundary condition, material properties, and then solve the case, and then compare data with the given data in the paper. So these things I will left as the exercise. You can do it very easily. Okay, thank you for watching this workshop, and I hope you have learned a lot of things here. And if you have any questions, please do ask me in the question answer section, or you can directly contact me through my contact details given in my Udemy profile. Thank you very much.